Teacher Chang here, and today we're going to go ahead and take a look at a point of concurrency called the centroid of a triangle. Now, the centroid of a triangle is formed by three medians from that triangle, and a median is created by taking the midpoint of one side and connecting it to the opposite angle, so it's the angle on the other side. What we're going to do is we're going to go ahead and find three of these medians. So we'll find one over here for the left side, we'll do another one for this top side going to the opposite angle, and then we'll do this other one at the bottom right going to the opposite angle. Now, where the three medians intersect, that is going to be our centroid. Now, the centroid will always be somewhere inside our triangle. And wherever that centroid might be, that is also known as the center of mass or the center of gravity. Because what you can do there is you could go ahead and put your pencil point on that point of that point of concurrency, the centroid, and what we can do is we can balance this triangle on that pencil tip. If we cut this triangle out and we find that centroid, we can put our pencil tip right on that centroid, and that triangle will balance out evenly. That's why it's called the center of mass or the center of gravity. In any case, let's go ahead and construct this centroid. Let's find out where that centroid is going to be. And in order to do that, we're going to go ahead and find out the midpoint of each of these sides and connect it to the opposite angle. So I'm going to start off with this left side over here. And to draw a midpoint, we're going to go ahead and do a perpendicular bisector. So I'm going to measure out my side to be a little bit more than halfway. And I'll draw an arc on both sides. And keeping the same setting, I'll put my tip on the other vertex and draw an arc so that the two arcs will intersect. Now, where they intersect, I could go ahead and connect these points, and that's going to go ahead and show me where the midpoint of that line is. So I'm going to go ahead and draw this line right over here, nice and light, and we can see that they intersect at this point right over here. Now, what I'm going to do with that point is I'm going to connect that point to the opposite angle. So that's all the way over here on the right. So I'm going to connect these points. And this is our first median. So the median is the distance or the segment from the midpoint of one side to the opposite angle. Now I'm going to go ahead and do another one, and I'll do the one right at the top of our triangle here. And we're only going to go ahead and do two of these, and the reason why is because, well, all three of them will intersect one another. So really all I got to do is two, because I know that the third one will intersect at the same location. So I'm going to go ahead and draw that perpendicular bisector the same way that I did before. Look for the points where the arcs intersect, and we'll go ahead and connect these points. That's going to help us locate the middle of our line, or the midpoint of this segment here, this side over here. And then we're going to go ahead and connect that midpoint. So it's cutting this line in half. We're going to connect that midpoint to the opposite angle, which is down here. So I'm going to go ahead and connect it, these 2 points here. And it's going to intersect the other median right over here, which means this is our centroid. Now, I could go ahead and find the midpoint of this line as well without doing the construction, because I know that the median will go ahead and touch that midpoint. So I'm going to take that opposite angle, go through that centroid, and when it hits that line, well, that's the midpoint of this third side. Okay, so what we just found was the centroid located inside our triangle. And again, the centroid will always be inside the triangle. Now, there is a special relationship in which the centroid will always have this ratio of 2:1. And that ratio of 2:1 is going to tell us the location of our centroid. So it has a ratio of 2:1. And what do I mean by that? Well, what I mean is that if I take a look at our median, it doesn't matter which one. I'll take a look at this blue one right over here. And that means this side right over here, from the angle to our centroid, or the centroid to the angle, this long piece right over here is going to be 2/3 of the entire median. Whereas the other side, from the midpoint to that centroid, is going to be 1/3 of our median. And it doesn't matter which median you choose. So if I went ahead and chose this green line over here, same thing. The distance from the angle to the centroid is going to be 2/3 of the entire median. And again, on the other side, from the midpoint to the centroid, well, that's going to be 1/3 of the entire median. And we could also do it on that last one as well. On the longest side, from the angle to the centroid, that is 2/3 of that median, the red one. And then on the other side, from the midpoint to that centroid, is going to be 1/3 of that median. So it has that special relationship of 2-to-1, where the medians, where the longer portion of that median closer to each of the vertex will be that 2, and the other side will be the 1. So here's our 2, and here's our 1. Same thing on the other ones. This is our 2-to-1, and here's 2-to-1. So it has that special ratio. All right, I hope this helped out. If you have any questions, go ahead and leave a comment. Don't forget to like the video and subscribe. All right, good luck, enjoy, and have fun.